First graph we are going to look at is the graph of y equals the square root of x. Now, all graphs can be worked out by finding pairs of coordinates. So if we start with x equals 0 and we find the square root of 0, we get 0. So it goes through 0, 0. There's no point going this way because we cannot find the square root of a negative number. So let's go this way. Square root of 1 is 1. Substitute in the square root of 2, we'll get a value of approximately 1.4. Work out the square root of 3, we'll get a value of about 1.73. Square root of 4 is 2. Square root of 5 is about 2.2. Square root of 6, about 2.45. Square root of 7, 2.65. Square root of 8, 2.83. Square root of 9 is 3. Square root of 10 is 3.16. And we could continue. But by now we should be able to see a good idea of what this graph is going to look like. Because we are only doing the positive square root, we only have positive values for the y values, so it's all above the x-axis. We cannot find the square root of a negative number, so we never go to the left of the y-axis down into the negative x's. We've got all those points and all the points in between. So now as we look at the graph, we can see that is the equation, that is the graph of y equals the square root of x. So let's consider what happens when, instead of having y equals square root of x, we have a little bit more complicated argument inside the square root. So for example, y equals, or f of x equals, the square root of x minus 1. You may recall, and looking at this picture, you can see that we have it stopping here on the axis at x equals 0, which is the very thing that makes inside here equaling to 0. If I was to look at this equation, the value of x that makes this equal to 0 is 1. So it's moved from 0 to 1. And we see the graph looks like that. It's exactly the same graph, it's just been translated 1 unit to the right. Now as we change this value here, we will see that this graph will continue to move across. So when x equals 2, when it's x minus 2, you'll see we have now moved across to the point 2. So this point of 0 has come across to 2. The value of x that makes this equal to 0 is 2. So it starts here at 2. And then it continues up in exactly the same way as before. And we can plot each of these points in exactly the same way as we did before. We can say x equals 3. The square root of 3 minus 2 is the square root of 1. And so that goes there. When x equals 4, we have the square root of 4 minus 2, in other words, the square root of 2, and that's 1.4, roughly, and so on and so forth. When we replace this 2 with a 3, so x minus 3, we'll see that we move further across. X minus 4, x minus 5. So we see we get essentially the same graph. It's just moving across from further across according to whatever this value is, whatever the value of x that makes this equal to 0. Now let's see what happens when we, instead of doing x minus 1, we do x plus 1. So again, using the same theory, what's the value of x that makes this section here equal to 0 when x is minus 1? Okay, So as I look at that, I see that it goes now through -1. And if I was to now go to x plus 2, whoops, then you'll see it's moved across to 2. And as you can see from changing the value, as this value changes, it is just moving further and further along according to what that value is. It's exactly the same curve, it's just sliding across from one side to the other.